let's switch gears here. We'll switch over to the demos. A couple things, little setup here. So John and I worked on a demo. First of all, what we're looking at here, you guys may have seen these before. This is a capture of a live demo here. So just to make the best use of everybody's time, we've got this demo to step through. John and I worked on putting this together, and when we showed it internally yesterday, some of the feedback we got was, well, why are you doing it this way? You're making it look like it takes 17 minutes to resolve a problem that could be solved in 2. So we're like, oh, okay, because we were like, oh, along the way, we can do this cool thing and that cool thing, whatever. But in the end, it made it look like a lot was involved to solve a problem. So we went back to the drawing board, streamlined this demo, and I'm going to explain what we're looking at here right now. But the first thing is that, we got together a couple of weeks ago to discuss how you guys were using the existing reports that we've been working with you on. And one of the use cases that was shared was about monitoring a primary circuit that fails over to secondary. We chose to demo around that particular use case, but the principles that we're showing during this demo are applicable, more broadly to the other use cases. So as far as what we're looking at here, it's pretty simple, right? We're passing traffic from the left, from this traffic generator to the right, passing this traffic through this little simple topology here, which is a redundant network topology that's running OSPF to handle the redundant routing. And typically when things are running well, the traffic is going to hit this VCP8 device, and it's going to pass the traffic north here to this VCP12 device and then on out. If things are not in a good state, then the traffic is going to get routed out VCP8 down to VCP13. 13 is not a good number, 13 is bad, and that's not where we want to be. Okay? Having provided that little setup here, we're going to go ahead and kick off this demo now. At this point in time, I might be actively monitoring this. I might be brushing my teeth. I might be on the golf course. Whatever it is I'm doing, NOM is still monitoring the infrastructure. And in this case, NOM has just detected that there's something going on. And by the way, one additional thing to add here is that we've added a utilization threshold actually on both of these interfaces. In our case, we said if the interface utilization on the primary drops below 5%, then that's going to be an incident. And then conversely, if the secondary interface picks up utilization, that's also something we're going to flag. I mean, we could set up these, there's also OSPF related events taking place. There's a number of things we could key off of. That's what we've set up in this case. And that's why we're seeing that these links are turning yellow. Like I said, I might be actively monitoring this, I might not, but regardless whether I am or I'm not, we detected that event and we sent out an email, in this case, confirming that there's something going on this GE002 interface on this VCP8 device. And it's worth noting that while we're showing this an email, we could just as easily be opening up a problem ticket right now and or taking any other action that's desired, in the data center here. But in this case, we're aware, we've been notified, we've minimized the mean time to detect here, we're aware there's a problem. And we understand from talking with you guys that you typically would not go to NNMI initially to look at this incident, this event, okay, that typically things would start off in the operations bridge interface. So that's fine. We come over to Operations Bridge and we can see that our incident has shown up in Operations Bridge for that VCP8 device and that GE002 interface. And if we open up the Operations Bridge incident, we can confirm this actually did come from NNMI. We see the interface that's affected here. We see the event type, which is the utilization being low. So we say, okay, let's take a look and figure out what's going on. We're going to open up the NNMI incident from within NNMI. I'll go ahead and maximize this. And we get a little bit more detail about this incident. We can see that we've measured the utilization at this point at 1.054%, which has fallen below our threshold These thresholds could be set differently. We're dealing with virtual devices in a virtual environment, and so sometimes there's interesting things that pop up. But nonetheless, this is still valid. The interface utilization has dropped down. We're aware of it. We need to fix it. We need to make our topology map go all green again. Green is good. So we need to troubleshoot. We come up to the actions for this particular incident, and we go to our troubleshooting interface. This is the 2022-05 incident workflow workspace that we were just talking about a minute ago. Similar to what we were just showing a minute ago, we can see that we've got the incident details, just like what we were showing. We can see that, let's see here, this is showing for the last couple of hours. The traffic has been flowing along great until we took a nosedive. And so at this point, the traffic is down at 0, which is why our threshold would have been violated. And similar to what we were talking about just a minute ago, on this timeline, about the same time that our interface utilization took a nosedive, we look up and we notice that there's this change indicator indicating that a device configuration change took place about the same time, this happened. So we can click on that to see some more information about, well, what was it that changed? And in this case, I can see that this change had something to do. A line was removed from the configuration, and a line specifically having to do with this interface that we're looking at. If I wanted to, now remember, the whole point is that we can troubleshoot and remediate everything from within this interface. But if there's some more detail, some more context I want to see around this change, I could click on this view, which will pop open another window. Now, like I said, what's going on here is something we could spend a whole call discussing, but for the sake of this use case and keeping things simple, what we're looking at here is a configuration change difference. So we've got the new config change on the right, and we can see who made the change at what time, and the old configuration on the left. And so basically at this point, I immediately see what the problem is, but breaking this down, we can see that this was an OSPF related change. And in this case, we can see, according to the legend up above, that we're going to show lines that were deleted, inserted, or changed. In this case, a configuration line was deleted. So that interface was cut off from OSPF, which would explain why the routing cut over to the secondary interface. We want to fix the problem, so we're going to come back to our incident workspace. And if we look at this incident detail for this device that's affected, we're going to see that there's some node actions that we could take. Now, this gets back to what we were talking about a minute ago. So when we go to deploy a change, maybe I'm okay with some tier 3 guy deploying a change directly to a device. Maybe I'm not. Maybe I want my tier 1 folks, or everybody for that matter, to have to go through a ticket, get approval that is supported, that's built in. And so in our case, we're going to go ahead and say, click on deploy change plan. And I might have predefined change plans. So in this case, maybe I've got my OSPF config already baked into a predefined change plan, or whatever the change might be. But in this case, I saw it was one line. I know it needs to be added. Instead, basically, I just want to push out the change that needs to be added. This device that we're working with happens to be a Juniper device, okay, not a Cisco device. We're supporting upwards of over like 200 vendors. We've got the broadest device support in the market today by far. But nonetheless, in this case, we're working with a Juniper device. We need to know what mode this command is going to be executed in. And so the system knows enough to know that, okay, well, if you're dealing with a Juniper device, I'll give you the Juniper modes. You don't have to go picking through a gazillion different modes for all the devices. So I select Junos configuration mode. In this case, I'm going to add or paste, whatever it might be, the command that I need to add to the OSPF config. And I can then deploy that out to the device. So clicking on deploy, okay, we're going to see a pop-up here that says we've successfully created this task to push out this change to the device. And if we come back to our topology graph, we're going to see everything is going to go green. We fixed the problem. And hopefully we have highlighted the fact that in the beginning, we minimized the mean time to detect. So we notified that the problem had occurred almost in near real time. And then by providing that incident workspace where you can basically look at everything on the one page, we've highlighted the fact that we're providing this ability along with those default metrics, by the way, that we're providing, as well as the ability to fix the problem from one place, that we're providing the ability to minimize the mean time to resolution or repair. So that is our demo. So yeah, there were lots of other stuff we were going to show, but the feedback was, you know what, just make it a day in the life and how you would affect it. There's any number of things that could have caused this failover to occur, right? And we could have had a circuit cut or whatever, but nonetheless, the principles are the same. We're still monitoring this. And in this case, we made it related to a config change and then detecting those changes in the thresholds. So in summary, if you recall, I said in the beginning how we shortened our initial pass at a demo to avoid scenic routes and stay on the main interstate. Here we demonstrated how the solution leads us directly from the problem to the resolution. We minimized mean time to detect with continuous monitoring and alerting, as well as minimizing mean time to repair with the one-stop shop NOM incident workflow implemented on top of the Performance Troubleshooter or PT canvas or workspace. So thank you for taking the time to watch this recording, and feel free to reach out if you have any questions.